Alright, you guys, this is section 1.6, Compound Inequalities, and we are on page 43 of our student companion. I want you to first, in that space underneath the name, write your I can statement, which is just write and solve compound inequalities. We're actually going to turn to example 1, and I'm going to explain what a compound inequality is. A compound inequality, over on the left-hand side where you can write notes, take the definition. Compound inequality really just means that there's more than one, at least two inequalities. So compound inequality just means more than one. And that is what we are going to work with now. We're going to work on writing a compound inequality. So what we're going to do is we are going to look at this graph that is given to us in our workbook and right here in front of us. We see that we have an open circle at -2 and we have a closed circle at 6, and we are shaded in between. So one thing we're going to take note of, we're going to remember that if we're an open circle, we are either the less than or the greater than symbol. And if we are a closed circle, we are either the less than or equal to or the greater than or equal to when we are writing these things on a graph, because that or equal to makes us be closed. So we're actually going to look at this graph and we're going to look at the shading to determine what is being said at each number. So if we are looking at right here at this -2, we have an open circle that is shaded to the right. So we are open and we're shaded to the right. So that means if we were to write a statement for that, we would say x, and since we are shaded to the right, the numbers to the right get bigger. So we would say greater than, and we chose greater than because of that open circle, -2. And that's how we would write an inequality for this shading. Now we're going to do the same thing for this +6. We see that we are a closed circle and we are shaded to the left. And think to the left of 6, the numbers are getting smaller. So if we were going to write an inequality for this, we would say x is less than, and since it's closed, it's actually less than or equal to 6. So what we've done here is we have written two inequalities, and that means we have more than one, so we can actually write this as a compound inequality. And if we were looking at this graph, we would see that we are shaded between, if I can write between -2 and 6 are what is shaded here, the numbers between -2 and 6. So when I want to write a compound inequality, I'm really just going to put it together. I'm going to put both of these together and write it as just one inequality. But if I wanted, since I want to do that and I want to know that x is between these two, I have to write it where the x is in the middle. So the x is between -2 and 6, and we're just going to bring down our signs, but what we're going to notice is that we've had to flip this around. So see how I want to put it with the -2 on the left and the x on the right because I want to write it as 1. So instead of writing x is greater than -2, I can write -2 is less than x. And I can flip that to get it to where, if I bring this down, x is, got that less than there. And if I bring this sign down, I've got the greater than or less than or equal to. And now I have this one compound inequality that says -2 is less than x is less than or equal to 6. And essentially, by putting this together like this, I am saying that we are between -2 and 6. But the key thing we had to do here was we noticed our two inequalities, so we wrote our two inequalities, but then I just flipped this one around to get the x on the right side so I could put them together and like smush them together as one inequality. And that's a compound inequality. And now we're going to start solving them. So when we solve this compound inequality, our first step, we're going to read the problem, and it's going to tell us to solve the compound inequality, and it gives us two inequalities with an or the word or between it. So that truly means we're this or we're that. And we're going to graph the solution. Our solution will be the solution of the first one or the solution of the second one. And the first step is just to solve both equations. So I've written both down and I'm going to solve them. So I'm going to start by subtracting 2 from both sides and end up with negative 3x is greater than. If I have negative 7 and I take away 2, I'm at negative 9. Then I'm going to divide by negative 3. And what we're going to remember here is if we are dividing by a negative number, what do we have to do with that sign? We have to flip it around. So don't forget to flip if we're dividing by a negative. And then my answer is going to be x is now less than 3. So I've solved the first one. Awesome. I'm going to remember that this is an or statement because sometimes we can be an and or sometimes we can be an or. This or that or this and that. Now I'm going to solve the second equation. I'm going to distribute that 2 and I'll have 2x minus 4 is greater than or equal to 6. Let me add that 4 to get that x by itself. And I've got 2x is greater than or equal to 10. If I divide by 2, now I'm not dividing by a negative number. I don't have to do anything weird with this. This stays normal. X is greater than or equal to 5. So the statement we have here is x is less than 3, x is less than 3, or x is greater than 5. And the way that we're going to graph this is instead of creating 2 number lines to show our solutions, we're just going to put them both on one number line together, following our directions with open or closed, and then we'll shade appropriately. So let's do the first one. We want to graph x is less than 3. So since it's just less than, I'm going to do an open circle at 3. Open circle. And I want to shade the numbers that are less than 3. And that would be to the left. So I shade to the left. And I draw a nice little arrow because I want to say that that keeps going. Now let's do the next one. X is greater than or equal to 5. If we're greater than or equal to, we do a closed circle. Close that up because we want to include that 5. And I want to shade the numbers that are greater than 5 or equal to it. And that would be over here to the right. And I'd shade that and draw a nice little arrow to say that it keeps going. So notice that your steps for solving are the same. Your steps for graphing are the same. You're just going to put them on the same number line. And we would read this as x is less than 3 or x is greater than or equal to 5. Because we have this little bit of space in the middle that's not included. That's why it's an or statement. All right, our last example is an and statement. So you're going to notice that the problem looks really similar. It gives you 2 equations, but it says the first equation and the second equation, and we're going to graph that solution. And our first step is to solve like normal. So let me distribute that negative 2. Negative 2x minus 2 is less than 4. Add 2 to both sides. Negative 2x is less than 6. We're going to divide by a negative 2. Ooh, we are dividing by a negative. Ooh, catch that negative. Guess what? Got to flip that sign. And we will have x is greater than negative 3. That's all we have to do is flip that sign around. This is an and statement, so I'm going to write that down just to remind myself that I'm going to be including both of these things. And let's solve this last one. Let me subtract 1 from both sides. 4x is less than or equal to negative 3 minus, oh, that's a positive 3. Oh no, it is a negative 3. Okay, negative 3, we take away 1 is negative 4. If we divide by a positive 4, notice how we're dividing by a positive number, so I don't actually have to flip that sign around. X is less than or equal to negative 1. And so now we're going to start to graph these. We're still going to graph them on the same number line. But since this is an and statement, we can write that as a compound inequality, like we did in that first example because of the and. So since I want to write it as a compound, I'm going to flip this dude around, and notice I want to write it as negative 3 is less than x, and now I can include this dude. X is less than or equal to negative 1. So I've written this as a compound inequality because it is an and statement, and that's going to help me graph. So let's see, this is a less than, and so that's an open circle at -3. This is a less than or equal to, so that's a closed circle at -1. And since it's a compound inequality, it's an and statement, we shade in between. Because this is essentially telling us that we are in between -3 and -1 is what that statement is saying. So I'll shade that in between. And if we read our original solutions that we solved for, x is greater than -3, check this side is greater than -3, and x is less than or equal to -1, check this side is less than -1. So we shade that in the middle. So essentially the difference is, if you look at both of these graphs, when it's an or statement, you're going to be shading the outside. So in or, you'll shade apart. And if it's, I can't spell, A-P-A-R-T, whoopsies, sorry y'all. And if it's an and statement, you'll shade in between. And that is compound inequalities.